Alright, yesterday we covered dependent events, bag of marbles. Um, Now we're going to move away from the spinners and the cubes and the coins and the bag of marbles, and we're going to move more towards real life events. We're going to learn how to tell the future um, by making educated assumptions using probability. The first word you need to copy down in your word wall is experimental. The L got erased, but an experimental probability is just like in science. When you do an experiment, you're doing something and recording data. So if I go outside and I shoot basketballs and I record how many shots I make out of how many shots how many total shots I took, that would be like a little experiment. So experimental For experimental, you're going to do trials. That's what we call in science when we do something to see how much an event happens, we do trials. So if I take 10 basketball shots, I did 10 trials. And then we're going to look at the number of favorable outcomes. Favorable outcomes and not favorable outcomes. So in an experimental, we're looking at, it's just like what we were doing before, a fraction, but we're looking at the number of favorable trials over the number. So the next word is trial, and that's just how many times you do something. So always look in our word problems, what is the total? And that's what I'm going to write here. Trial is like the total. And total is a very important word because we can't do a percentage unless we know the total of something. All right, the next word we're going to have is predict. Predict, what does predict mean? It means to tell the future. It means to tell the future. Now, it would be nice to be able to accurately tell the future. All of us would be millionaires and we'd probably be on an island somewhere. So probability is not perfect, but it does give us a hint towards what's going on. The next word, our words, are buzzwords. And when I say buzzwords, I mean when you're on the talk test and you're reading a question and you see the words expect, possible, would, should, then you know you're dealing with a prediction problem. And you know you're going to have to do a fraction, and you're going to have to look at total, and you're going to have to look at number favorable or number not favorable. And you're ultimately going to set them all up into proportions, which is what we learned last 9 weeks. Proportions are not going to leave us. They're going to be with us for the rest of the year. Half of the TOX test is proportion. Of the TOX test, that's proportion. Probably 3 to 4 of the TOX questions, or 3 to 4 of the questions will be something that has to do with predicting or telling the future. All right? And a proportion, as you know, is just two fractions that are proportional. Now, one of the things that we're going to practice today is setting up the proportions with words so we get an idea of what to do. Now, let's go back to the example I said over here. I go outside in the basketball courts, and let's say I take shots. And I can look at how many I make over how many total. Okay? And I want to make sure whatever's in the problem, when I set up my proportion, I have the same relationship on the other side. Make over total and make over total. So let's say I make 6 shots out of a total of 10 shots. Well, I can make a prediction. How many do you think I'm going to make out of 100 shots? And we'll get to how to do that today. But those of you that know how to do the proportion, either monkey or butterfly, or cross multiply and divide, it's going to be 60. Let's go ahead and look at some examples. If everyone can, turn to their daily work and look at number 1. Now remember, always look for your buzzwords. Should, predict, could, possible. Alright, the question is, the results of a random survey show that 42 out of 80 people would have voted for Obama. Which is the best prediction of the total number of votes he will receive if 2,000 people vote for him? Now that's in the future. We don't know. But if 2,000 people were to vote on a later date, what would be the total number that voted for him? So let's go ahead and take the math out of here. All right, the key word, again, the buzzword is best prediction. Now will or would is another one. Those words let you know that we have a proportion going on. Would, could, should, best prediction, best indicator, those are buzzwords. Now let's go ahead and go to the first piece of information they give us. It says 42 out of 80 people would have voted for Obama. Okay? So let's put that in words. What we're doing is we're looking at the people that voted for Obama out of the total number of people. So I need to make sure that Obama over total equals Obama over total. Okay, so the proportion should look like that, but with numbers instead. So let's go ahead and take this first one and put it in our proportion. Okay, it says 42 out of 80 people voted for Obama. So the 42 is the Obama, the 80 is the total. And then it gives us a third number. And it says, what is the best prediction of the total number of people? So we do not know, hone in on what you don't know, we do not know the total number of votes he will receive if 2,000 people vote. Well, it doesn't tell you that this 2,000 is total, but you have to know that what we're trying to look for is the total number of votes that he would receive. So this number right here, 2,000, is the total. Okay? So now we're back to proportions. Now we can do this several ways. You guys know how to do monkey, where the number is trying to swing to the letter. Doesn't know how, so ask the bottom, how do you swing to the top? That only works with numbers that are divisible. And just looking at this, 80 cannot go into 2,000 evenly. I mean, I can get a decimal, but it's not going to give me something nice and neat. Just to get you guys ready for algebra, let's go ahead and do butterfly. Let's multiply 42 times 2,000. And let's multiply 80 times x. Well, I like 80 times x because it's just 80x. That one's easy. I don't know it, but I do know that it's 80 times a number. Now, if you want to put a parentheses around the x to help you remember it's multiply, that's fine. Now I have 42 times 2,000. Well, 42 times 2 is 84, and there's 3 zeros, so I'm going to add my 3 zeros. All right, now I'm at 80 times a number equals 8,400. Well, algebraically speaking, to get rid of the 80, we'll divide by 80, cancel it out, and divide by 80 over here. Now what we're doing is just cross multiply and divide. That's all we're doing. So now we have this fraction, which doesn't help us much. So we're going to put it into a decimal form. So what goes in the box? 84, 1, 2, 3. What goes outside the box? 80. Again, do yourself a favor. Draw some lines. Less mistakes. And ask yourself, does 80 go into 8? No, it does not. 80 doesn't go into 8. Does 80 go into 84? Yes, it does. One time. I'm going to do 80 times 1, and then I'm subtracting 4, bring down the 0, and I'm going to ask myself, does 80 go into 40? No, it does not. So I'm going to put a 0 on top, drop another 0. Does 80 go into 400? Yes, it does. It goes into it 5 times. 80 times 5 is 400. It's 0. I'm going to drop this last 0. And 80 goes into 0 0 times. And once I'm done, that's my answer. So I can expect that 1,050 people will vote for Obama. So this X right here is 1,050 people. Now ask yourself, does this make sense? Let's look at 40 and 80. Is 40 about half of 80? It's a little more than half, right? Well, now look at the other side. Is 1050 about half of 2000? Yes, they're proportional. So if you did your division right, you should have two fractions that are proportional. Now, if you would have gotten, let's say, 10500, does that make sense? Or if you would have gotten 105, would that have made sense? No, those answer choices don't make sense. All right. Remember, the first thing you have to do is set it up in words first. If you're not going to do that, you're asking for trouble. All right, let's go ahead and go to the second problem, and let's read what it is. The probability of a tennis racket being defective is 1 out of 10. About how many tennis rackets would be defective in a case of 275 tennis rackets? All right. The key words. All right, obviously they tell you it's a probability problem. And then they throw in the word would. All right, those are big indicators that we're dealing with a prediction problem, and we know we're going to have to do proportions. But here's the tricky part. They give us a fraction. Now remember, for a proportion, you need 3 numbers, but that fraction is kind of weird. We're used to seeing 3 individual numbers. Well, let's think about this. The probability of a tennis racket being defective is 1 out of 10. So what does this 1 mean? It means that there is 1 defective tennis racket out of 10 total. That's what's going on. So I can write over here defective over total equals defective over total. That's the proportion. If those numbers don't match up with those ideas, you've set up the proportion wrong. All right, so let's go and go to our fraction. I know 1 is defective and 10 is the total, and they give me a third number. It says about how many tennis rackets would be defective. So the would be defective, that's our question. We don't know how many are defective, but we do know that there are 275 total rackets. So that's going to go on the bottom. 275. All right. I have my proportion again. Last time I did butterfly. I'm going to go ahead and try to do monkey. It's not going to work. because this doesn't end in 0. Maybe the next one will be monkey. So I'm just going to do cross, multiply, and divide. If the algebra wasn't working for you, this is exactly like algebra. Cross, multiply, and divide means I'm going to multiply the two numbers that are across from each other. 1 times 275 is 275. Now, I'm going to divide 10 into that answer. So this answer that I got here, I'm going to put inside of a box. And 10, the third number in my proportion, is going to go into this number. So let's go ahead and draw some lines here so we don't make mistakes. Can 10 fit into a 2? No, it can't. Can 10 fit into a 27? Yes, it can. Twice. It goes 2 times 10 is 20. I'm going to subtract 75. Can a 10 fit into a 75? Yes, 7 times 70. I'm going to subtract. I'm going to go into decimal land. 10 goes into 50.5. 27.5. All right. In real life, we can't have 27.5 rackets. A half of a racket can't be defective. Well, the top half could be broken, but it's defective or not defective. So this 27, a reasonable answer, we would round it up. So we would say 28 rackets are defective. Okay? All right, let's do a common sense check. These two numbers right here, the 1 and the 10. 1 is small, a lot smaller than 10. It's 10% smaller. Now let's look at this. Is 27.5 10% smaller than 275? Well, if I divide 275 by 10, yes it is. So common sense check passes. All right, ways you can mess this up. Obviously, if you do defective over total, and you don't think about what this third number is, and do it like this, you're going to be incorrect. Okay? Watch for the pitfalls. All right, let's go ahead and go to number 3 on your daily. Rick played an electronic game. There were 15 questions, of which 3 she answered incorrectly. At this rate, how many questions should Rick expect to answer incorrectly if he answers a total of 135 questions? All right, so Rick played a game and there were 15 questions. I've got to be thinking, is that 15 questions total or is that a part? Before I begin, let me go ahead and circle my buzzwords. This word right here, expect. That's the word that tells me we're talking about a prediction problem. Expect, predict, they're synonyms. Well, similar synonyms. All right, there were 15 questions, of which 3 she answered incorrectly. All right, incorrectly is tied with this number 3. So 3 incorrectly and 15 would be the total number of questions she asked. So we're talking about incorrect and total. So my other proportion should also have incorrect and total. If those numbers don't line up with those words, we're in trouble. All right, so let's go ahead and look at our first fraction. There were 3 questions she answered incorrectly. So I know that the first one is 3 incorrect and 15 total. Now here's where the problems come in. At this rate, how many questions should Rick expect to answer incorrectly? Did you guys see the question? The question is, we don't know how many she's going to answer incorrectly. If there are a total of 135, they did you a favor. They gave you the word total. So 135 is my total. Now, watch out for pitfalls, guys. All I have to do is change this word to correctly, or vice versa, tell you that 135 is how many she got or he got incorrect. It changes your proportion. We'll get to those later. All right, so here's my proportion. It checks out correctly. I have 3 over 15 equals x over 135. All right, let me look at this question. Let me see if I can do a monkey on this one. I know that 3 is trying to swing to the x. That's how monkey starts off. You're always trying to swing to the letter first. So I'm going to ask the bottom, how did you swing to 135? Well, it just so happens that 15 times 9 gives me 135. Well, if I do times 9 on the bottom, then I can do times 9 on the top. 3 times 9 is what? 27. So we know that Rick is going to get 27 questions incorrect out of a total of 135. Common sense check. 3 is smaller than 15. Is 27 smaller, about the same rate smaller than 135? It's hard to tell, but you know if it was 2.7, that would probably be way too small. And you know if it was 270, you went higher, so you did something wrong with your math. Always do the common sense check. I hope you're starting to see the pattern of what we're doing. It's going to be kind of the same thing over and over, except they may change what numbers go on top and what go on bottom. For the most part, they keep it pretty consistent, but you never know what's going to come at you. A random survey, and I'm on number 4, a random survey of 75 8th graders at Slider Middle School showed that 37 of them are on the AB honor roll. Use these results to predict the approximate number of students who are on the AB honor roll out of 1,000 8th grade students at Slider Middle School. Well, I'm going to go ahead and look for my buzzwords first. I know that when I see predict, I'm talking about a probability and a proportion problem. So now my brain is already looking for 3 numbers, and I happen to have 1, 2, 3 numbers. So now I got to figure out what categories they go into. All right, a random survey of 75 8th graders at Slider Middle School showed that 37 of them are on the AB honor roll. Okay, so let's go ahead and look at that 37. 37 of them are on the AB honor roll. Okay, and this is a survey that we took, and how many people were asked in the survey? There were 75, and that was the total number of students in our little survey. Now remember, going back to statistics, we can't ask all of the 1,000 8th graders, so we just ask a small section to get an idea of what we're doing. Statistics and probability are like brothers and sisters. They go hand in hand. So I know that my next one should be, my next fraction that I have should be AB honor roll and total. All right, so let's look at our first fraction. Well, it's given to us. It says that 37 are on the AB honor roll, and 75 are the total number of students that we asked. And then it says, use these results to predict the approximate number of students who are on the AB honor roll out of 1,000. So we want to predict the number who are on the AB honor roll. We do not know this. This is a question mark. We don't know that. So I'm going to put on top an X because I don't know AB honor roll. But I do know that there's 1,000 students at Slider. Alright, on this one, it's probably best just to cross multiply and divide. Again, I'm going to cross multiply the two numbers that are diagonal from each other. And I have 37 times 1,000. Well, if you know the trick with multiplying anything with 1,000, you just count the number of zeros, write down the original number, and then write down the number of zeros. Alright, now I'm going to divide by the lonely one. I always called it CMD, Club CMD. Two are having a party, and one wants to get in the party. Let me see if I can... Hey, my numbers just jumped. Did you like that? Alright, do yourself a favor and draw some lines. Every time you say no, you're going to put a 0 at the top. Can 75 go into a 3? No. Can 75 go into a 37? No. Can 75 go into 300, 3,700, 37,000? Yes, it can. You can do the math off to the side, but it is going to equal 4. And let's go and do that. 75 times 4 is 20. 28 is 300. I'm going to do my subtraction. 370 minus 300 is 70. Drop a 0. The next one, it's going to be 9. And I'm going to do my math off to the side. 75 times 9 is 45. 63 is 67. And it's 675. And this is going to be 25. And I'm going to drop a 0. And this is 250. 75 into 250 is going to be 3. Let's go 75 times 3. It's 15. 7 times 3 is 21. And 22. But we're going to get the same thing over and over. It's going to be 73, or 493.3 repeating, going on forever. Common sense check. So x equals about 493. I'll let you round for that. Common sense check is 37 about half of 75. So the common sense check, 37 is a little less than 75, halfway there. 493 is about half of 1,000, a little less than half. So the common sense check works out. Last problem. So the time recorded that 27, I think that's supposed to be Tim. We'll just say time. Time recorded that 27 out of 63 customers used a shopping cart at a grocery store. Based on these results, about how many customers out of 350 can be expected to use a shopping cart? Again, I'll kind of go through the fast. We've done enough examples. Expect, that's the word that tells you we're dealing with a proportion here. And I'm going to look at my first set of numbers. 27 out of 63 customers used a shopping cart. So 27 used a shopping cart out of a total number of shoppers. Okay, so this other one is going to be shopping cart over a total. Same thing. Okay, so the first number tells me I'm going to put 27 over 63, and the second set of number, or the second number, based on these results, now this is where it's key. You got to read carefully. How many customers out of 350 can be expected to use a shopping cart? This is what we do not know. Always ask yourself, what do we know, what we don't know? We don't know the shopping cart. So we see that shopping cart's on top, so we're going to put an X on top. And they give us a third number, and it's 350. All right, this one, I'm going to have to do cross multiply and divide. I'm going to do 27 times 350. You can do the math off to the side. 350 times 27. You can also use lines on this to make sure that you line everything up nice and neat. 7 times 0 is 0. 7 times 5 is 35. 7 times 3 is 21. Plus 3 is 24. I'm going to put a place marker on my first row. 2 times 0 is 0. 2 times 5 is 10. 2 times 3 is 6, plus 1 is 7. So it equals 0, 5, 4, 9. And it's 9,450. Now I'm going to divide by the lonely number. So I'm going to put 9,450 into a box. And then I'm going to put 63, because it wants to get into this party, out of the box. I'm going to do myself a favor and put some lines so I don't get confused. And put my decimal up top. This was 9. All right, 63. Can it go into 9? No, it can't. 63. Can it go into 94? Yes, it can, one time. 94, take away 63, is 31. All right, bring down your 5. Can 63 go into 315? Yes, it can, 5 times. Let's do the math on the side. 63 times 5 is 15, 31. It's exact. 315. I'm going to subtract 0, bring down my 0. And can 63 go into a 0? Well, it goes into it exactly 0 times. So x has to equal 150. Common sense check. 27 is smaller than 63. 150 is smaller than 350.